at this point, I think it is time to stop teasing the code and actually write some code. So let's turn on some automatic scene switching. And let's dive in. Okay.
Roman Rudikov. It's okay.
Cool. Okay. So welcome everyone. This is my first attempt at actually planning out a live coding thing in advance. Did a test a few days ago and there was no audio, so I'm glad everyone can actually hear me.
You sound loud and clear.
Perfect. Okay. Cool. And actually, it is a little bit on the loud side for me over here. So I'm actually going to turn off the, I don't know how to turn it down, so I'm just going to turn off the voiceover, and I will, and I'll read it myself. So just give me a sec. Perfect. Okay. Perfect. All right. So the goal today is, let's see if we can get an HTTP reverse proxy set up in Rust. So I will admit in advance, I've done this once before, so I'm cheating a little bit. But on the other hand, the last time I did this with the older version of Tokyo and Hyper. So there's a new version. There's a new version of Tokyo. There's a new version of Hyper out. And there are definitely some changes. So most likely we're going to run into some funny things as we're going through this. I'm going to go ahead and explain as we're going. People definitely drop in some questions as you've got them. So let's look at the ecosystem. Oh, and just so you know, what I've got here is a freshly minted brand new project. So we are going to be doing some compiling. Wanted everyone to get the full actual experience. All right, so let's pop open main.rs. Okay, everything's just going to end up living in this main module. We're not actually doing anything too terribly complicated. So the first thing we do, let's go ahead and turn this into an async function, and let's apply Tokyo main, which of course is not going to work right off the bat. So we're going to start pulling in dependencies. Now I'm going to do this the right way, and I'm going to go through the documentation with everyone. So over here we can see we've got Tokyo version 101, but we're also going to need to turn on some feature flags. The easiest thing I could do would just be to turn on full. I think for purposes of learning these things a little bit, we'll start off by being a little bit more explicit about which features we want to turn on. So let's go ahead and have a look at which feature flags are available. Full is going to pull in all of these. I'm definitely going to need macros. I mean, I don't need macros. We could do it the ugly way, but I prefer using the macros. The macros are wonderful. And if you don't know what I'm talking about, you'll see it very shortly. We don't need process. Net is going to get included automatically. We're going to turn on RT multi-thread. We could just do the runtime. We don't actually need the multi-thread. This is something that, if I remember correctly, is brand new in Tokyo 1.0. Let's see, sync. I don't think we need sync. And I don't think we need time either. So I'm going to leave them off. If it turns out that we need them, we can add them in later. So let's go ahead and get that saved. And now you can see we're already building this. If you can see down here in the bottom, we're already building this for VS Code's integration, but I'm also going to do a cargo run and let that build so that I'm also able to run this thing. Okay, so while that's building, let's go ahead and check out the other library, the other main library that we're going to be working with, which is Hyper. Hyper is the web library we're going to be using. 0.14 is freshly out, and it's compatible with the new version of 1.0, of Tokyo 1.0. So I'm going to be pulling in Hyper, and one of the changes, I actually checked the change log. So there is a little bit I wanted to do this fresh, but I also wanted to avoid any kind of major foot guns on the stream. One of the changes with Hyper 0.14 is now a bunch of the feature flags are turned off by default. So we want to have client support, HTTP 1 and 2, server support. We don't really need the stream support. I'm not sure about the runtime support. I'm just going to go ahead and throw in full because we need basically everything anyway. We're going to do that. We're also going to need to pull in some kind of TLS support since we are going to be reverse proxying over TLS. And if I'm not mistaken, I could actually be mistaken about this one, the Hyper TLS crate, which is the thing that most people use most of the time, the Hyper TLS crate is not yet updated to Hyper 0.14. On the other hand, Hyper Rust LS, I'm not actually sure how I should pronounce that. This one is updated. So I'm going to go ahead and pull in hyper ls. Let's go ahead and jump into the docs. And we can go ahead and have the same view and look at the feature flags and see if there's anything in particular we need to enable. If I remember correctly, the answer is no. Hyper rust ls. So I should probably leave off the features bit in this case. All right, so the default, it's going to use native Tokyo runtime. Yeah, I think we're fine. So in this case, we're not actually going to need any feature flags. We'll just use the defaults. So I can simplify this TOML down to looking like this. Okay, cool. So now we can actually start looking at some code. And I'm going to kick off this build one more time so it builds all the additional packages. So looking at this code, we've got an async function for main. Right now it's just doing the default println, and this is the macro that's kicking off Tokyo. So we've got our runtime initiated and we're able to start doing asynchronous things inside of this. Question is, how do we get started with writing a reverse proxy? There are two sides of this. We need to be able to make outgoing HTTP requests, and we need to be able to receive incoming HTTP requests. Since I want this to be a little bit interactive, let's go ahead and get started right off the bat with trying to do some kind of outgoing requests. And I'm going to reverse proxy. Oh, that's right. I think we're going to reverse proxy today to http-bin.org. Assuming it's actually active. All right. Now, http-bin is available over non-TLS and over TLS. We'll go ahead and make the request to the TLS version of it to make sure we're using TLS correctly. Okay, cool. So let's start off by figuring out how exactly using raw hyper we would make this kind of a request. So here's the documentation for the crate. Here's the documentation for the hyper crate. And hyper is where we're going to want to work. And keep in mind, this is a low-level crate. For convenience, it's much better to use the request crate. Request is not yet updated to 0.14 and to Tokyo 1.0, so you do need to keep that in mind. But let's go ahead and check out our client module. So the client, we want to go ahead and create a new client. And I learned the hard way the last time I did this. I should have been aware of this. The default of what's going on here is not going to support TLS. So we can just go ahead and jump right over to how do you create a client that supports TLS by looking at the rust.ls, hyper rust.ls package. And fortunately, we've got a nice little example right here. So it's going to start a runtime. We don't need that. Get a URL. We are going to need that. And we're also going to need some error handling because I am allergic to panicking. That terrifies me. But we can go ahead and create, oh, this is interesting. I don't think I saw this last time. That's right. Last time around, I did not use the rust.ls package. So this is a first for me. So we're going to use client builder. Let's go ahead and check out what that looks like. Where is client coming from? Now that's coming from hyper. So we're going to use the client builder, and then we're going to use the HTTPS connector with native roots. Okay. I think we are safe at this point, trusting the authors of this package to tell us what to do just a little bit. And let's knock off a few names. Okay. Now, why is this failing? Type annotations needed. Ah, okay. So there is some trait magic going on there. Let's go ahead and put that in and use hyperclient. Okay. So now we've got our client. Let's jump back to the documentation. How do you make a request? We are going to block on client.getURL. Perfect. This is not going to be a good idea long term, since we're going to have to deal with more general requests than just GET requests. But let's go ahead and take a stab at this. I'm going to start off with the unwrap, and we will replace it with something else afterwards. All right, so that worked. What's the warning we're going to get? It's a future, and the future needs to be used. This is a wonderful warning from Rust, so let's go ahead and wait. Now we have a result that we need to use. And again, I'm just going to unwrap. We'll get rid of all the unwraps afterwards. Let's get the response, and then let's do the laziest thing possible and print out the entire response. So, are we lucky? Did we just make an HTTP request with Rust? Looking pretty good. Okay, so we got the headers. Everything worked fine there. The body is a little bit of a different story. Let's go ahead. I do actually want to get the body. Let's find a simpler example. For people who aren't familiar with it, httpbin.org is a very nice tool if you're ever working on writing a client HTTP library, which I've done. So it's nice to have something like this. Let's see, is there something? Let's just get status code. I wanted something with JSON response inspection. Why am I not finding the thing I'm looking for? I don't care about dynamic. Ah, here we go. So we're going to go ahead and response format. I want a JSON because of course everyone wants JSON, and of course it's as simple as /JSON. So let's go ahead and put in /JSON as our URL. And let me disable a few more programs so y'all don't get spammed. Okay. Cool. All right. So now we see that the content type is application/JSON. The question is, how do we get the body? Let's go ahead and jump into the types here. Now, the reason why I like Hyper, and I'm a little disappointed at the work that I did over on the Haskell side, Hyper actually did manage to keep the same types of request and response for both the client and server side. Something that I know some people in the Haskell community wanted to get done originally. Right now in the Haskell side, between HTTP client and the Y, they have completely different types in play. So, okay. Anyway, let's continue on. We've got response. The question is, how do you get the body? And this seems like the simplest thing to do. It returns a reference to the associated HTTP body. The body by default is going to be of type body. Let's just go ahead and grab this. Let body equal. Now, in reality, we don't actually need to worry about this because of what I just mentioned, the fact that the request and response types are the same. We're going to see pretty quickly that doing a reverse proxy, you don't have to do much manipulation on the request. But I still want to see what's going on here. So unused variable body. What is the type of this thing? It is a hyper body. And let's go ahead and see what a body looks like. So it is a string of bytes. You can check if it's empty. And is it through the future implementation? Maybe it's through the future implementation. So you can convert it. You can see over here the implementations. You can convert it from bytes and a number of other things. But down here, where is the future implementation? Maybe that wasn't it. Wrap stream. I take it back. I'm not quite certain. Oh, it's the stream implementation. You have to explicitly deal with it as a stream. Okay, so streams are like iterators, but they live at the async level. Now let's go ahead and play around with this. This is going to require the stream feature, but fortunately, we enabled all features. The stream trait has this poll next, but that's not typically the way that you end up interacting with the stream. So let's go ahead and check it out. Stream required methods. This is coming from features core. Oh, interesting. Let's start off by just trying to print out the body. I don't remember what it actually produces. And I'm fairly certain it is not the entire contents. Yeah, body streaming. Mm-hmm. Oh, stream extension. That's what it is. Okay. Next. Creates a feature that resolves to the next item in the stream. Okay. Okay. Cool. So let's go ahead and try to say while let sum equal body dot next. I think we're going to run into an error pretty quickly. See what the problem is. No method name next. Items can only be used if the trade is in scope. Not a surprise. So the question is, where does this stream extents come from? And it comes from, I thought it was exported also from Hyper, but I'll just go ahead and use it from futures util. Where was this thing located? Stream. Mismatch type. Oh, shoot. Can anyone hear me? Okay, connection should be reestablished. I'm not sure what happened there. Can someone confirm that the stream is back? Stream finished. That's disappointing. Okay, that was just, oh, that was on YouTube. All right, can anyone see me now? All right, so YouTube is down. That is unfortunate, but it looks like we've still got Periscope and Twitch. All right. It does look like it's still active on Twitter, so I'm going to continue going. If anyone can weigh in. I guess the people on YouTube who can't see me can't weigh in anymore. All right. Cool. All right. So anyway, let's continue with the coding. So what I was trying to figure out here is what exactly do we do in order to grab the data out of here? All right, so I thought that for a stream, there's some kind of a next method. I thought there was a next that worked just like, oh, there's pull next. Pull next was not it. There's some documentation in here somewhere. There's something that is supposed to work similarly to the way that things work with an iterator. All right, since this isn't actually vitally necessary in order to implement what we're doing, I'm going to go ahead and skip over this. If anyone has questions about it, wants to do other things in the future, let me know. For the moment, we've got an outgoing HTTP request, so that's good. let's go back and address some of the poor error handling. We have lots of different ways of improving this. I'm going to take the simplest approach. And the simplest approach, in my opinion, is to use the anyhow crate. I just did a training video on the various ways of doing error handling in Rust. But let's go ahead and pull this in. Anyhow is just a trait object, which allows you to capture basically any kind of error that may happen. So yeah, we're going to pull that in, and I'm going to be incredibly lazy. I'm just going to say use anyhow star, the futures util stuff, and I'm going to return result of unit. And let's actually stick a unit there at the end. All right, so now to be a little bit nicer about things, we're going to context URL with the $sign operator. We're going to get that URL. Here we're going to await, and we're going to say context performing HTTP request. Stick a question mark at the end. All right, we don't need that body down here. Let's go ahead and see what happens. Compiling anyhow, reverse proxy. Okay, cool. So things are still working. At this point, we've done enough on the client side. Let's take a little bit of a break from that and jump over to the server side, which is where things are going to get a little bit more interesting. Now let's jump back over to Hyper. The documentation is pretty good for being able, in fact, let's just go ahead and jump into the guides, do a little bit more copy pasting of things. So we've got a server. Let's see, the documentation is still on version 0.13, which may or may not be a problem. The two things that we're going to end up looking at are make service function and make service, and service function. Make service function, here, let me make this a little bigger. Make service function is you give it a function which is capable of making a new service function. And then this is the actual service function, the thing that is going to service incoming requests. This is going to get called for each thread. I think for each thread. Anyway, I don't know if this has changed in 0.14. So this is where we get to explore some of the fun stuff. Let's go ahead and check out this server. So we're going to starts a builder with the provided incoming stream. That's not what I'm looking for. Server bind is where things are going to get started. All right. So server bind is going to create a new builder. Let's go ahead and get started with that. I'm going to comment this out for now. I'm going to leave this stuff up here with the client because we're going to be using it again a little bit later. All right, so now let's server equal. Let's go ahead and cheat again. Nice, easy way of getting a socket address. Socket address comes from that. Can't believe I got that right. And I like this. We'll go ahead and bind directly on 127.0.0.1. Actually, I don't like that so much. We'll listen on 0.0.0.0, meaning any IP4 host, and we'll listen on port 3000. I'm getting a little spooked that no one's responding to any of the messages. Let me check out directly on Periscope for a moment. See if messages are coming in there. Just don't want to be missing out on any of the chat messages coming in. Okay, cool. If anyone has any questions, definitely feel free to pop them in. I'm more than happy to answer some questions. All right. So we've got our we've got our address that we're going to bind to. Let's go ahead and set up our server. We're going to bind to that address. Cool. Hi, Lambda Mom. That would be Miriam. Thank you for helping me test out this stream and keep things running. All right, so bind. Let's look at the type for bind because it's not working the way it's expected. Why is my type information not working? Interesting. All right. We'll go ahead and pop over here and let's look at bind. It takes a reference to a socket address instead of an address, a socket address directly. Cool. So now comes the important bit. We have to serve. This, honestly, this is the part that drives me the most crazy about Hyper. Granted, Hyper is not intended to be a high-level, easy-to-use library, but the type here is completely unparsable, in my opinion. So you do have some nice examples. The examples make it clear how to work with it. So let's just go ahead and take advantage of those. Make service function and service function are the two helpers. All right. So we're going to say we're going to serve now make service function. I'm going to do this incorrectly at first, just so everyone can see how difficult the error messages can be to parse. Expected closure. Yeah. Hey, Travis. Yeah, I see the message. I don't know why the YouTube stream stopped. So maybe I can, I'm not sure. People at least are able to do this on Periscope, and I'll post the video. I am recording separately from YouTube, so I will go ahead and upload the complete video to YouTube afterwards. So apologies to people over there. Okay, cool. Basically, there's very little information that comes out of make service function from the types themselves to tell you exactly what you need to be doing here. You do need to provide it some kind of a lambda. It goes from a target to a ret, but even here, the information is basically inscrutable. Took me a while to really understand what I was supposed to be doing here. The fact is, though, if you just follow the follow the documentation and you do things the way they recommend it, things basically work out okay. The idea is you're going to go ahead and provide it a closure. This closure is going to take in a value, and if I remember correctly, the value is the socket address of the client that's connecting, and then you give it back a future, and the future needs to return a result at the end, and inside that result, that's where you're going to go ahead and provide this service function. Service function is going to be a very similar kind of setup. It's going to take a request, and then you give it an async block and give back a result wrapped around a response. So let us go ahead and copy paste that for now. And we'll do a little bit better shortly. Instead of make service function, we will provide the thing I wrote up there. That's fine. We need to include response in here and body. Okay, so now we've got a server, except check out the warning, unused variable server, not a surprise. What exactly is this server? Or how do you run the server? Let's go ahead and check out the docs again. Is this the right one? Yeah, so we're looking at the serve function. The serve function gives you back a server. If I remember correctly, which I think I do because it's not that long since I've looked at this, the answer is, oh, right, I'm doing this from scratch, so it might be slightly different. I thought it was just run, but maybe it's not anymore. See that it has an implementation of future extension. Maybe, okay, let's check out the trait implementation. The future trait implementation gives you back a result. So I'm guessing the run function is no longer necessary, and instead we can do .await .context running server like that. We're still getting a warning about the client not being available. Theoretically now, we should be able to run this. Now if I connect to localhost 3000, we should get, you guys can't see that, but I'm getting a security alert about opening up a port. That's fine. But now, if I... So, things are actually working. All right, hold on. I'm getting distracted because I got Periscope open incorrectly over there. Cool. Yep, so our beautiful web server is working. All right, so we've got a web server and we've got a web client. We don't have to do this next part, but I'm going to do it anyway, because why not? I want to go ahead and have our client go ahead and talk to our server. So we've got the address that we're listening on, we had a URL. Now let's go ahead and separate these things out a little bit. Now, instead of connecting to HTTP bin, I want to connect to localhost. I'm going to connect to localhost 3000. I'm going to parse it. And let's go ahead and take this bit, our response, and send it. This is not going to do what we want it to do. It's not actually going to print anything. It's going to block forever. And the reason is because we've actually been sitting here with our server running, and only when the server exits, which never happens by default, only when this server exits are we finally going to actually make our request, which doesn't happen. So instead, what we want to do is we want to do that as a background thread. So let's just go ahead and play with that because it's fun. And the easiest way to do this, I'm going to wrap all of this in a Tokyo task spawn. In fact, I don't have to do a Tokyo task spawn. I can just do Tokyo spawn. All right. And now I'm going to give it an async block inside. I think I'm going to need an async move, but we'll just start off like this. And this is going to go inside too. And we've got a little bit of a problem because this is not returning a result. And now it can't figure, now the type annotations don't work. This is definitely a frustrating bit. We need to explicitly tell it, and I'm going to use the turbofish approach. We need to explicitly tell it that this is going to be an anyhow result. Did this work? Wrong number of arguments, expected to, fine. So in the OK case, it's going to be unit, and in the error case, it's going to be an anyhow error. Oh, geez, I'm being very stupid. OK just needs to know the OK and the error. Does not need to see the result itself. Async block may outlive the current function, but it borrows address. Next problem. Instead of borrowing address, let's move it in. Actually, it might make more sense to do the address from inside, but it doesn't really matter. There is a little bit of a race condition here because we're going to spawn this task, and then we're going to try to make our HTTP request at the same time that we are trying to start our server. I'm fairly certain this is going to fail, in fact. Let's go ahead and see if it fails or not. Yeah, it succeeded. My guess is if I ran it enough different times, it would fail. Probably a better approach, though, would be to wait until the binding actually goes successfully, and then push something into a mutex or something along those lines, some kind of a trigger to let the client know that it can go. A very dumb way of solving this problem, I think I didn't enable the time one. A dumb way of doing this would be to just sleep in the main thread. Let's go ahead and throw in time support. It's going to require a little bit of rebuilding. Oh, maybe it doesn't. Okay, cool. I'm going to do Tokyo colon. Oh, that's right. Things got renamed. Hold on. So now I'm really glad I'm looking at this because I was curious. So Tokyo 1.0 is basically the same as 0.3, but I didn't really get to play with either one of them very much since Hyper only just was released, so I was stuck with Tokyo 0.2. Let's see the modules that we're going to work with. There is a time module. Time module provides, oh, it's sleep. It is sleep. Okay. I was just overcomplicating it. And let's just delay, not millis, I want it millis. Let's just delay for half a second. If I just stick the semicolon there, by the way, I get a nice warning telling me that I've got a future, but I didn't use it. Calling sleep doesn't actually do anything. It creates a future. And in order to actually make this wait, I've got to call .await. All right. So now I recompile this. And yeah, the compilation times or the linking times at least are a little bit on the slow side. It's giving me time to drink my coffee, which is nice. Yeah, so things work. And if I wanted to, just so we can see something. Okay, let's see how that goes. Cool. Okay. So we're good. So now we have the ability to talk to our own server, run our own server, talk to our own server, and talk to external servers. Now we can start looking at what is it going to take in order to run a reverse proxy. And this is the fun bit. So inside here, inside Tokyo spawn, we've got a request. We want to modify that request in some way. We're going to be receiving a request from the client. We want to modify it. And the main way we want to modify it is we want to change the host name that it's going to talk to. Ideally, we should strip off some request headers because some request headers should not be resubmitted. Things like the accept encoding. Anyway, transfer encoding. There are a few different ones. And in fact, when I need to do something like this, unfortunately, I have not found an official piece of documentation anywhere that provides a list of the HTTP headers that need to be stripped. I do have this, yeah. So I have these four as content length, transfer encoding, accept encoding, and content encoding. These are basically at the transfer layer. They're not part of the actual request. This is from my Haskell package that does reverse proxying. Anyway, so let's go ahead and say what we want to do is we want to change the destination host of where this is going to go. We want to change it to, let's reverse proxy to snoima.com this time. So right now, if you go to snoima.com/blog, you get redirected, and then you end up at this. In fact, the announcement that this thing was going to happen, and the YouTube video, which includes the cutoff stream. So anyway, we want to now make it when I go to 127.0.0.1 3000/blog, I want it to take me there. Right now, it's not going to do anything because I'm not running the server. But if I was running the server, then it would actually just give me the hello world message. One thing I forgot to mention, so when we spawn this task into the background, this task does not prevent the server from exiting, the process from exiting. If I wanted to do that, I could say let server handle this, and then I could wait for that. Is that right? I'm probably missing something. Oh, that's giving it's a result of a result. So 2 layers of results. That happens sometimes. the task itself could have panicked, or it could have aborted in a bad way, and then the result we're giving back from the process could also give some kind of an error. So now actually our server continues to run since we're waiting for that, that background task to complete. And now we get our hello world. But again, that's not the thing we actually want to be doing. So let's go ahead. The magic here is going to be about looking at this request type and modifying it so that it is it's pointing to the right destination. So let's go ahead and pretend mutate request. It's going to take, let's look at the type here. This is going to be a request parameterized on body. So I'm going to say request body. Oh, and I want a mutable reference to it. I distracted myself. And I want to go ahead and put request up here. So now down here, I'm going to make this a mutable parameter. I'm going to mutate request on this thing. And now we're going to get to see some fun error messages around ownership. This is the part that always bends my mind. Hyper. All right. So what we want to do is we want to use the client that's up here. So we're going to do client the same. In fact, let's just go ahead and cheat and look down here. We just did client.get. Get is incorrect. So let's go ahead and look at the hyper documentation and look at how do you pass in a request to a client and get a response. There's new, is that it? No. So client, no, builder. Ah, this is it. Take it back. This is it. Client.request, you give it the request and you get back a response future. So seemingly a piece of cake. So client.request rec, and then we are going to await it. We're going to say context. Context, by the way, is a method that comes from the anyhow package. Making request to backend server. And now, instead of returning that, I'm going to do that. Now, we don't need to go through all those hoops. Now what? Oh, and I forgot, I need to mutably borrow that. Now we get into the fun stuff. Client does not live long enough. So client is is a borrowed value. We could start, basically the client is now getting moved in to this async block right here because we've got a move here. Then we've got a closure. And this is not a move closure. So it's going to start borrowing things. Because of the way that futures work, because of the whole lifetime concept going on here, the client cannot be guaranteed to live long enough for all of this. So the question is, what do we do? The most direct solution I can think of for these kinds of cases, thank you. Wonderful wife brought me a new cup of tea. Just in case anyone's wondering, I have a little bit of a cold today, so if I sound a little gravelly, that's all it is. So tea refill is essential. Okay, so I left on a cliffhanger. What exactly are we going to do here? What we want to do is we want to be able to share this client across all of the different connections that we've got going on here. And the most straightforward way to do that is to use an arc. So an arc, an atomic reference counter. So now client, we're going to wrap it up. So why is this giving an error message? All right, so we don't need any of this stuff down here. We'll put this to the side. In fact, let's simplify our code just a little bit more. We don't need any of the spawn stuff now. Maybe we'll come back to it in a little bit. We don't need the async move. We are just going to be, running this thing directly. We have a single thing we're doing, a single task, and that task is going to be to launch our server. So we've gone ahead and created our client. Oh, arc new syntax? Sure. This is, so it's a method. Arc is a type. This is a static method, so it's namespaced inside that type. So arc new is a function. So we're grabbing the new function from there, we're passing in a value, and the result is going to be arc client. Okay. And it turns out this URL is not being used at all, so now it doesn't know what it's trying to parse, but we don't need it anymore, at least not yet. All right, so we've got an arc client. What are we going to do with this thing? Well, down here, we still have the same problem. Client doesn't live long enough. We can go ahead and we can, yeah, no problem. So what we can do is we can start marking all of these things as move. And this gets kind of interesting. So we're going to say this is move. We want to move the arc. We want to move this client value in here as opposed to borrowing it from main. We're going to move here. Let's start looking at the error messages. Cannot move out of client, a captured value in a fn mute closure. Move out of client occurs here. So it occurs on line 19. This is really mind-bendy stuff, at least for me. I think I learned a lot about ownership and closures by trying to get this to work the first time I played with it was a few years ago. So at this point, what's going on here? We need to be able to spawn off these additional, we're going to be spawning off additional tasks, additional things. Each one of them needs to be able to own its own copy of this arc, meaning we have to clone this arc all over the place. For those who don't know, arc reference counted, an arc is reference counted. Sorry, hold on. Getting some notifications that I thought I disabled. Just going to kill those. Okay. So an arc is reference counted. We need to be able to clone it each time we want a new copy. And the trick is to do something like this, like client equal client.clone. If you saw my most recent blog post on FP Complete, you may also think that a good way of doing this is arc clone, just to be very explicit about which kind of cloning we're going to do. All right. So this still doesn't work. And this was tricky for me the first time. We actually need to do this over here. So we're going to say, now that we're inside our closure, okay. Now that we're inside our closure, we've moved client in there. Before we start this async block, which is going to create a future value, and that future value is going to have a different lifetime, we need to do the cloning first so that we can move the cloned copy of client into the async. Let's go ahead and fix up we're going to fix up the screwed up nesting. Okay, layer 1 of this problem complete. So now we have the same kind of problem. Closure may outlive because it borrows client. So now we're inside this async block and we are going to return another closure. So let's go ahead and stick a move on here. And if we stick an async move here, we end up with the same kind of mistake that we had previously. So we'll do this, we'll do this. And now, once again, let's make another clone. And we're good. So we've gone ahead and made 2 copies of this. First, each time we generate another make service, and then when we generate another service, we're going to make additional clones. Now, if I run this right now, it's not going to work because we haven't actually implemented mutate request. But let's, have some fun anyway. Okay, cool. Now if I come over here and I reload, page isn't working, and sure enough, panicked because it's not implemented on line 8. The question is, how do we mutate this request? I'm going to come over here to the hyper documentation. Okay. And let's go ahead and look at what a request looks like. So we've got headers mute. Returns a mutable reference to the associated header field map. So I said that there were 4 different things that I wanted to delete from that. Let's just go ahead and do that. We get back a header map. Let's look at what a header map consists of. It gives us, it's not give delete, it gives us remove. So let headers equal request.headers mute, headers.remove. In fact, be a little more clever. And again, I'm just stealing this directly over here from the Haskell code. So for each of these things, I want to do request.headersMute.remove key. And I need to borrow this. What's the problem here? Okay, so a reference to a reference to a string. Let's go ahead and deref that. All right, we're good. That's one of those cases where deref coercion doesn't work quite the way you would expect. All right. I'm going to go ahead and make this request. No, I'm not going to make this request. I don't want my computer to crash on us. Right now, the request still has the original host name, the original destination. If I go ahead and make a request against this, this is going to cause an infinite loop. The server is going to receive a request. It's then going to try to reverse proxy, but it's going to reverse proxy to itself, so on and so forth, and that will go on forever. So instead, we do need to pop back over here to the documentation and see how do you change the destination. This was honestly the most irritating part of dealing with this last time, because as you're going to see, the URI type, well, maybe if we just use parse, everything's going to be okay. All right, so we've got URI mute, and this is going to allow us to mutate what's going on with the destination. Let's look at this URI type. Unfortunately, this is the part that irritated me. URI, at least in Hyper 0.13, was its own defined type as opposed to reusing something from another package, and it didn't. Oh, maybe things have changed. Before I say too much, let's go ahead and look at this. All right, so URI's got the authority, which surprisingly enough, authority means all this stuff. It's also got the scheme, which we're going to want to modify. So the question is, how do you modify this? How do you generate one of these? So try from, okay. Yeah, I think the easiest way to do this, maybe not the most efficient, but the easiest way to do this is to generate a URI string using format. So we're going to say, we want to connect to https:// Yeah, we're just going to do it this way. This is easier than what I've done in the past. And what are we going to connect? What other things do we need? The final thing we need is path and query. Yeah, that's it. So path and query is going to come out as an option. Let's just go ahead and I don't remember. I think it comes with its own slash at the beginning. I'm going to kick this all off by just doing a panic on the URI string so we can see if we generated something at all reasonable. Okay, so request dot URI dot query. All right, URI is a method, not a value. All right, good. And what's the error message we're getting here? So we have an option of path and query. I don't remember offhand why it would be an option. Well, path, maybe it's actually easier to just deal with the path and the query separately. Yeah, that's easier. Yeah, it's going to be easier. And it's going to contain both relative and absolute path. Okay. And as we can see, the path does in fact include the leading slash. So let's say match request.uri URI equal request.uri. Match URI dot query. So if it's going to be none, we are just going to return the path, no query string. And if it includes a query, then we are going to include the query string. And let's just panic so that we get a nice little error message and we can see if it's doing the thing we expect it to. Right. Unused import response. It's fine. I'm not actually going to use that. Compile. All right, moment of truth. What happens when I reload this? Nice. Panic.uri string. It's giving exactly the URI, the string that we wanted. Let's go ahead and stick a query string on the end. Yep, it's doing the right thing. Awesome. Okay. So next, we want to parse this into a URI and then set it. So we're going to say request.uri mute equals URI string.parse context parsing URI mutate request, and we'll put a question mark on the end there. Now we've got to actually return a result instead, and we'll have to deal with that down below. That's fine. Oh, and we've got to deref that. Okay. And if this all succeeds, and we'll return an OK. Yeah, we'll return an OK. All right. Now we've got a warning down here because we're not using that result, and I'll just stick a question mark there. All right. We may be done. Boom. Oh, well, it redirected all the way over here. Let's try that a little bit differently. And that's it. We've got a reverse proxy. Woohoo. I've got one little tweak that I want to add to this, but before I get into that tweak, anyone have any questions? Anything that you want me to hit over here? Cool. Okay. So the only other thing that I was thinking of is we should do some kind of a status check. Right now we're just passing all the responses through directly. So let's go ahead and add a special /status page. So we're going to, in here, do some kind of branching. Match request.uri.path. Oh, here, let's do it more simply. If match request.uri.path just do a to do for now. Else. Gotta say, to do is much nicer to type than unimplemented. So what kind of errors are we getting? Okay. So now if we go to /status, we should get our error. let's go ahead and go to /status. Perfect. Exactly what we wanted. Question is, what do we want to return instead? And I think, well, the question is, okay, I want to keep some stats. Let's keep this really simple for the moment, and we'll just have proxied requests, and that's going to be a U size. I'm going very simple on this one. So now we're going to, every single time, so we want to keep some set of stats in here. We could just create another arc holding on to the stats, but then we're going to have to thread it through the whole way. So I'm going to create an app value. It's going to be a pain. What's the full type of this client? Yeah, I'm going to have to type in that whole thing. Nah, let's just go ahead and do it the easy way then. I'm going to create an arc, but I'm not just going to have an arc. I need to have an RW lock on this arc. So RW lock allows for interior immutability so that we're able to lock, modify things, but you're able to do a read-only lock, which is non-exclusive, and a write lock, which is exclusive. So we've got our client and we've got our stats. Arc, RW lock, stats, arc new, RW lock new. And I should create a default implementation for stats, but I'm going to be lazy. And instead, I'll just go ahead and put in proxy 0. All right, so we've got stats there. Let's go ahead and thread it through the exact same way that we did with the client. Okay. And here, do we actually need to? Oh, we may need to. All right. Yeah. All right. So now that we've gotten this far, in the case that we actually proxy one of these things, I want to immediately stats.write.unwrap. I know I said I'm allergic to unwraps, but in this specific case of lock poisoning, we really don't have anything else we can do. Why is this giving me an error? Oh, because it's giving back a guard. All right. Okay, so it's doing exactly the right thing. Plus equals 1. Am I crazy? Oh, right. Stats proxied. There we go. We don't actually need to wrap that in a block because we're not creating any kind of a temporary variable that's going to hold on to the lock. All right, so now we've gone ahead and incremented proxied each time. Here, sorry everyone. So now I want to just generate some kind of a response in here. I'm going to do stats. All right. Cool thing, you can use .into to convert string. I think you can. All right, because it's only got a display debug instance, not a display instance. So I can't use toString, but I can use this. And then once I have the string, I can use .into in order to give me back a body. And now I just have to generate a response. Response new body. What exactly is the issue? And I also have incompatible types. Oh boy. Okay. Actually, that's not such a big deal. Oh, it's going to be a big deal. Yeah, it's still going to be a problem. All right, so the problem of what's going on here. An async gives you back a value which implements the future trait. Each time you've got a different async block, there may be a different underlying type present. So the fact that I've got two different async blocks going on means that there is theoretically the chance that each one of those is going to give back a different type, more than theoretically. So we're not able to unify these two things. There are two ways that I can see to solve this. One of them is simple and one of them is complex. The complex one is to use some kind of an either type, to be able to say an enum of A and B, and say this is the A case, this is the B case, and then they're able to unify. That sounds complex. Yeah, it's kind of complex. It's not the worst thing in the world. The simpler thing to do, though, is just to wrap all of this inside an async block instead of having the async block inside. Let's just go ahead and do the simple thing, and we're going to have to make a few interesting changes to our code in order to make that work. The important one, here. Go ahead and indent that properly. Now we're going to run into a, we're still running into that? Shouldn't be running into that anymore. Maybe I'm wrong. Expected hyper, oh, I still need to wrap this in an okay. Cool. Cannot move out of stats, a captured variable, in an f and mute closure. Boom. That's the thing that I was a little bit more interested in seeing. We need, now that we've got an async move, an async block around this stuff, we can't use stats directly. Instead, we have to clone it first. Here we can just do this trick. And we've got to move our client cloning to be before we start off. Now you can see why I kind of wanted to go back and create a helper type that unified these two things together, but not such a big deal. So it's building. All right, now let's check things out. Boom. So we've got a read, write, lock, read guard. I didn't actually expect that to be present. We can probably get rid of that. So let stats and I'm going to have to deref it. I think. That's enough. Cool. Okay. Now I'm going to do stats like that. Cannot move out of a dereference. All right. Cool. Can't move out of it, but I can borrow a reference after it's been derefed. So now that value, now let's wait until this thing actually finishes compiling. Cool. Right. Oh, so it's going up even though it hasn't actually proxied the request. The reason it's gone up will make a lot more sense if I include a little bit of output down here to say the path that was requested. In a good application, I would use the log package instead of using println, but this is fine for now. Let's go ahead and see what this other thing that's getting proxied is. Should be intriguing. I have my guesses. All right. 0, 1, 2, 3, 4, 5. Cool. Yep. Favicon. Browsers love requesting favicon even if they don't need them, or even if they've got to them. Actually, on snowman.com, I don't have a favicon.ico. And that's the problem, right? Oh no, I did have a favicon. I don't know why it's requesting it again and again each time I hit refresh. But anyway, let's go ahead and go to the blog. and it's doing a full redirect. So I've hit refresh a few different times. Now we should see things jump quite a bit. Because it's not just reloading the HTML over there, it's pulling in the CSS and a few other JavaScript files. So we're in good shape. So now we've actually seen how we can not only do a reverse proxy, but we can also inject some custom behavior. One of the things that I often do with these reverse proxies is implement some kind of authentication and pass in some auth tokens as request headers to the underlying application. Okay, cool. This is really about as far as I'd intended to get, and it's about the time that I intended to spend on the coding. Anyone have any kind of questions before we break? And by the way, if anyone has feedback on this, this is definitely an experiment. The issues with YouTube, not surprising maybe. If anyone's wondering, I've been using Restream. I did use Restream for this. I think in the future I'm not going to bother using Restream, and I'll just target one platform at a time. Interested if people prefer Periscope versus YouTube. Okay. Any kind of questions? Not seeing anything. Cool. Awesome. Okay, everyone. Thank you very much. I can go back to the loading screen. Okay. Anyway, that was great, everyone. Hope everyone has a great rest of the day. If you have any kinds of requests for future streams or videos, let me know. Have a good one. Talk to you later.